Types and operation of shop and flight line fire extinguishers. Water extinguishers are the best type to use on Class A fires. Water has two effects on fire. It deprives fire of oxygen and cools the material being burned. Since most petroleum products float on water, water-type fire extinguishers are not recommended for Class B fires. Extreme caution must be used when fighting electrical fires, Class C, with water-type extinguishers. All electrical power must be removed or shut off to the burning area. Additionally, residual electricity in capacitors, coils, and so forth must be considered to prevent severe injury or possibility of death from electrical shock. Never use water-type fire extinguishers on Class D fires. The cooling effect of water causes an explosive expansion of the metal, because metals burn at extremely high temperatures. Water fire extinguishers are operated in a variety of ways. Some are hand-pumped, while others are pressurized. The pressurized types of extinguishers may have a gas charge stored in the container with the water, or it may contain a soda-acid container where acid is spilled into a container of soda inside the extinguisher. The chemical reaction of the soda and the acid causes pressure to build inside the fire extinguisher, forcing the water out. Carbon dioxide, CO2, extinguishers are used for Class A, B, and C fires, extinguishing the fire by depriving it of oxygen, Figure 1-4. Additionally, like water-type extinguishers, CO2 cools the burning material. Never use a CO2 on Class D fires. As with water extinguishers, the cooling effect of CO2 on the hot metal can cause explosive expansion of the metal. When using CO2 fire extinguishers, all parts of the extinguisher can become extremely cold and remain so for a short time after operation. Wear protective equipment or take other precautions to prevent cold injury, such as frostbite. Extreme caution must be used when operating CO2 fire extinguishers in closed or confined areas. Not only can the fire be deprived of oxygen, but so too can the operator. CO2 fire extinguishers generally use the self-expelling method of operation. This means that the CO2 has sufficient pressure at normal operating pressure to expel itself. This pressure is held inside the container by some type of seal or frangible disc that is broken or punctured by a firing mechanism, usually a pin. This means that once the seal or disc is broken, pressure in the container is released and the fire extinguisher is spent, requiring replacement. Figure 1-5. Halogenated hydrocarbon extinguishers are most effective on Class B and C fires. They can be used on Class A and D fires, but they are less effective. Halogenated hydrocarbon, most commonly called Freon by the industry, are numbered according to the chemical formulas with halon numbers. Carbon tetrachloride, halon 104, chemical formula CC14, has a Underwriters Laboratory UL toxicity rating of 3. As such, it is extremely toxic, Figure 1-6. Hydrochloric acid vapor, chlorine, and phosgene gas are produced whenever carbon tetrachloride is used on ordinary fires. The amount of phosgene gas is increased whenever carbon tetrachloride is brought in direct contact with hot metal, certain chemicals, or continuing electrical arcs. It is not approved for any fire extinguishing use. Old containers of halon 104 found in or around shops or hangars should be disposed of in accordance with Environmental Protection Agency regulations and local laws and ordinances. Methyl bromide, halon 1001, chemical formula CH3Br, is a liquefied gas with a UL toxicity rating of 2. It is very toxic and corrosive to aluminum alloys, magnesium, and zinc. Halon 1001 is not recommended for aircraft use. Chlorobromomethane, halon 1011, chemical formula CH2C1Br, is a liquefied gas with a UL toxicity rating of 3. Like methyl bromide, halon 1011 is not recommended for aircraft use. Dibromodifluoromethane, halon 1202, chemical formula CBr2F2, has a UL toxicity rating of 4. Halon 1202 is not recommended for aircraft use. Bromochlorodifluoromethane, halon 1211, chemical formula CBr-C1F2, is a liquefied gas with a UL toxicity rating of 5. It is colorless, non-corrosive, and evaporates rapidly, leaving no residue. It does not freeze or cause cold burns and does not harm fabrics, metals, or other materials it contacts. Halon 1211 acts rapidly on fires by producing a heavy blanketing mist that eliminates oxygen from the fire source. More importantly, it interferes chemically with the combustion process of the fire. Furthermore, it has outstanding properties in preventing reflash after the fire has been extinguished. Bromotrifluoromethane, halon 1301, chemical formula CF3BR, is also a liquefied gas and has a UL toxicity rating of 6. It has all the characteristics of halon 1211. The significant difference between the two is halon 1211 forms a spray similar to CO2, while halon 1301 has a vapor spray that is more difficult to direct. Note, the EPA has restricted halon to its 1986 production level due to its effect on the ozone layer. Dry powder extinguishers, while effective on Class B and C fires, are best for use on Class D fires. The method of operation of dry powder fire extinguishers varies from gas cartridge charges, stored pressure within the container that forces the powder charge out of the container, to scooping pails or buckets of the powder from large containers or barrels to toss them on the fire. Dry powder is not recommended for aircraft use, except on metal fires, as a fire extinguisher. The leftover chemical residues and dust often make cleanup difficult and can damage electronic or other delicate equipment.